I hope it's visible and you can also hear me, I think. Isn't it?
Yes, sir.
So last day where we stopped, what did we find as a result of analysis? For the sake of generality, I considered a two-sided sequence and inspected its Z transform. So it was found that the Z transform of the causal part of the sequence, that Z transform, it has a region of convergence outside the circumference of a circle centered at origin in the Z plane. While the Z transform of the anticausal part of the sequence, that was converging in the interior of a circle centered at origin in the Z plane. And only if there is an overlap between the two region of convergences, the Z transform of the entire sequence will exist. Otherwise, Z transform won't exist. Now let's move on to certain examples to make it more clear, and certain other important findings are also to be seen. First, what I'm trying to do, first I'm explaining, then I'll allow you sufficient time to write down. So we are considering an infinite duration causal sequence for the sake of illustration. So xn, it's a to the power n un. So it's an infinite duration causal sequence. If you find out the Z transform from the basic expression, this is the expression. You can also write it in this manner. And under what condition will it converge? Where will it converge? It will converge if magnitude of Z is greater than magnitude of A. Then this power series representing the Z transform, it will converge to 1 by 1 minus a z to the power minus 1. So that is the Z transform of the infinite duration causal sequence, and it will have a finite value for magnitude of Z greater than magnitude of A. That means in the outside of a circle centered at origin in the Z plane having a radius equal to magnitude of A. So that is the observation. Exterior of a circle of radius magnitude of A is obviously centered at origin in the Z plane. Now, this is the ROC. If A equal to 1, that is a particular special case, the sequence becomes a unit step sequence and the Z transform becomes 1 by 1 minus Z to the power minus 1. ROC is magnitude of Z greater than 1. This is the case for A equal to 1. Consider another example, that of an infinite duration anticausal sequence. Infinite duration anticausal sequence. So it exists for, it has no, it can take on non-zero values only for n less than 0. All right, for n greater than equal to 0, it is identically 0. So that is what is meant by anticausal sequence. And I am considering an anticausal infinite duration sequence. So start from the basic expression for Z transform. This is the basic expression. In this expression, you just replace, just 1 minute. In this expression, you just replace minus n with m with minus n. All right. So if you have a series of this form, you know that its summation of this series will be c by 1 minus c, provided magnitude of c is less than 1. So here in this expression, on substituting m equal to minus n, because the summation extended from n equal to minus infinity to n equal to minus 1. That's why in this expression, minus n has been replaced by m. So we have landed up with that type of expression. Now, in this case, this summation is of similar nature, isn't it? So what will be xz, that summation? It will be minus a to the power minus 1 z divided by 1 minus a to the power minus 1 z. That means 1 by 1 minus a z to the power minus 1. 1 by 1 minus a z to the power minus 1, provided magnitude of z is less than magnitude of a. So in these two examples, you are finding something very interesting. So what is that interesting fact? In this case, the ROC is interior of a circle of radius equal to magnitude of a centered at origin in the z plane. Interesting fact is that the earlier infinite duration causal sequence a to the power n un and this anticausal sequence, they have the same expression for z transform. They have the same expression for z transform. All right. But the ROCs are different. The z transforms differs only in the region of convergence. In the earlier case, it was magnitude of z greater than magnitude of a. Here it is the magnitude of z less than magnitude of a. In the earlier case, the ROC was the exterior of a circle centered at origin in the z plane. And here it is the interior of a circle centered at origin in the z plane. So, two things. It has again been observed that if you have an infinite duration causal sequence, then the ROC will be the entire exterior of a circle centered at origin in the z plane. If you have an infinite duration anticausal sequence, the ROC will be the complete interior of a circle centered at origin in the z plane. That is one part of the story. Second part of the story is that if you simply state the z transform without stating the ROC, that is not a complete information. Suppose I give you a function of z in the form 1 by 1 minus 3z to the power minus 1, and I mention nothing about the ROC, and I ask you to find out the inverse z transform. Can you do it unambiguously in absence of the citation of the ROC? You cannot, because there are two possibilities. All right. So observation is that closed form expressions of z transform of sequences a to the power n un and minus a to the power n un minus n minus 1 are identical, but their ROCs are different. So it reveals two facts. One is uniqueness of z transform. For a given sequence, there can be a single expression for z transform. Second is non-uniqueness of inverse z transform in the absence of mentioning of the ROC. All right, without the ROC, you cannot move from the z domain to the time domain, sequence domain. All right. Thus, a uniformly sampled signal xn is uniquely determined by its z transform xz and ROC of xz. It can also be seen, as I have already mentioned, ROC of z transform of infinite duration causal sequence is the complete exterior of a circle. And for the infinite duration anticausal sequence, it's complete interior of a circle centered at origin in the z plane. Now you may write down. If you have any question, please ask me.
Sir, why it is called power series converge means?
This is a power series. This type of series is called power series.
Oh,
All right.
okay.
Series in powers of az to the power -1.
Oh, अच्छा, अच्छा, हाँ. Thank.
Have you written it?
Yes, sir.
Next is that anti-causal infinite duration sequence. Remember that both of these sequences, causal and anti-causal, they have infinite duration. We will also have a look at finite duration sequences. Finite duration causal sequences, finite duration anti-causal sequences, and finite duration uh, two-sided sequences. We will consider a infinite duration two-sided sequence, but remember that we have already discussed about infinite duration two-sided sequence. All right. Again, we'll consider that. As you have observed that for infinite duration causal sequences, the ROC will be the exterior of a circle. For infinite duration anti-causal sequences, it will be the interior of a circle. What do you think? What will be the case for infinite duration two-sided sequences? I have considered that. What do you think? Infinite duration two-sided sequence?
So entire Z plane except
No,
ZL
no, no,
0.
no, no, no. It will be a ring-shaped region. Ring-shaped region centered at origin in the Z-plane. So this is the region where the ROCs of the Z transforms of both causal part of the sequence and anti-causal part of the sequence will converge. Common region where they will overlap. So that will be the ROC for infinite duration two-sided sequences. Done it. Now the observations.
Sir, can you go back up? I didn't finish.
Yes. এই জলের গ্লাসটা একটু বদলে দাও না। এই দোয়েল জলের গ্লাসটা একটু বদলে দাও, কিছু ময়লা লেগেছিল।
Thank you, sir.
Yes. I hope we understand what is meant by uniqueness of Z transform and non-uniqueness of inverse Z transform. For a given sequence, the expression for Z transform is unique. You cannot have two different expressions for Z transform for a given sequence. But for a given function of Z, if you want to find out the inverse Z transform, there are more than one possibility. Two possibilities are there. So unless you are provided with the information about the region of convergence, there will be non-uniqueness of inverse Z transform. If the ROC is also provided, information of the ROC is also provided, you have complete information about the inverse Z transform. All these deliberations on the region of convergence, we have to consider that because in this digital signal processing, we can come across two-sided sequences or two-sided signals. Signals that can take on values for t greater than 0 and also for t less than 0. All right. That was not the case for continuous time signals. We only had causal signals. Signals that are identically 0 for t less than 0 for the continuous time case. But here there can be, in digital signal processing, there can be two types of processing. One is real-time or online processing, where a stream of data is coming in and the data is being processed by some algorithm and immediately it's thrown out for useful purpose. Second type of application I have already pointed out, that the data that is coming in, digital data, that is stored in memory location, some memory device, and later on it's retrieved for processing. So that is called offline processing. When you are performing offline processing, the choice of the origin of time rests on you. So you can select the origin of time in such a way, you have to select, you will find that there will be samples to the left of that origin of time and also to the right of that origin of time. So that will be the case for offline signal processing. So that's why we are considering such detailed analysis of the ROC of Z transform. After you complete writing down this much, next example is on two-sided infinite duration sequence of the form xn equal to a to the power n un, that is the causal part, plus b to the power n u minus n minus 1, that is the anti-causal part of the two-sided sequence. So if you consider the Z transform for such a sequence, this is the expression for the Z transform. Basic expression, fundamental expression for Z transform. Xz equal to summation over n equal to 0 to infinity a to the power n z to the power minus n. That is the Z transform of the causal part. And second summation represents the Z transform for this anti-causal part. Because for the causal part, the terms, the sample values for n less than 0, that will be absent. So summation extends from n equal to 0 to infinity. And for second part, the anti-causal part, samples for n greater than equal to 0, that will be absent. So that's why this summation extends from n equal to minus infinity to minus 1. And over that span, un is 0, un is 1. Over this span, n equal to minus infinity to minus 1, u minus n minus 1, that is 1. So here un is 1, here u minus n minus 1 is 1. So that's why you have come up with such an expression. So I have carried out mathematical maneuvering. This is the expression for the summations. First summation, it will converge if magnitude of z is greater than magnitude of a. And second summation will converge if magnitude of z is less than magnitude of b. All right. In other words, the ROC of the Z transform of the causal part, it will be the exterior of a circle in Z plane centered at origin and having a radius equal to magnitude of A, while the Z transform of the anticausal part, it will be the interior of a circle centered at origin in the Z plane with radius equal to magnitude of B. Exterior of a circle centered at origin in the Z plane with radius magnitude of A. Interior of a circle with radius magnitude of B. So what will be the region of convergence of XZ? Obviously, region of convergence of XZ is the common region. That means the region where both these ROCs overlap. That is the region where both these Z transforms, they will converge. So for the convergence of XZ, it is necessary that each Z transform represented by this summation, they should also converge. Therefore, the common area of convergence will be the region where these two circles, they overlap. There may be case where the circles will not overlap. In such a situation, the Z transform will not exist. Z transform of Xn will not exist. So I think you have written it. All right. Case 1. Magnitude of B is less than magnitude of A. The two ROCs do not overlap. Hence, XZ will not exist. I have just cited a typical case when B is 1/3 and A is half. That means if you have a sequence xn equal to half to the power n un plus 1/3 to the power n u minus n minus 1, then the Z transform of xn will not exist as indicated by that condition. Second is when magnitude of B is greater than magnitude of A, there will be a ring-shaped region in the Z plane with inner radius equal to magnitude of A and outer radius equal to magnitude of B, where both the power series, both these power series, this one and that one, will converge. All right. So in that region, both the power series will converge simultaneously. Therefore, in such a case, xz will be the summation of these two terms. So that will give rise to a minus b z to the power minus 1 divided by 1 minus a plus b z to the power minus 1 plus ab z to the power minus 2. And here the ROC will be magnitude of z greater than magnitude of a less than magnitude of b. Now please try to find out whether if I add these two terms, do I really land up with such an expression? Please check that. Is that expression correct? Thus, we can make this observation that if there is an ROC of the Z transform for an infinite duration two-sided sequence or time series, another name for such sequence is also time series. It is an annular region centered at origin in Z plane, or a ring-shaped region centered at origin in Z plane. Observe the language. If there is an ROC, because there can be case when there will be
Sir,
no ROC. Yes, please, please. Please.
could you go up once more? I got disconnected for a while, so I could not write down that part.
Which part?
The case 2 part. I just missed out a bit.
Oh, if magnitude of B is greater than magnitude of A. All right, this was the case when magnitude of B is less than magnitude of A, then the ROCs of the two terms will not overlap. There will be no overlap. All right, I'll illustrate it later. This is the situation. This is the situation for the first case, case 1. Magnitude of A is greater than magnitude of B. So the anticausal part, Z transform of anticausal part is that one, while Z transform, the ROC of the Z transform of the causal part is this one. So the two ROCs, they don't overlap in such a case. So XZ does not exist. In the second case, I am considering that magnitude of B is greater than magnitude of A. In that case, see, the ROCs will overlap. So that overlap, what will be the shape of that overlapped region? It will be a ring-shaped region or annular region. Inner radius will be magnitude of A, outer radius will be magnitude of B. So in that case, the shaded region will be the ROC of XZ. And XZ will have such an expression. All right. These are the two cases. The illustration of the two cases. Left hand side is for case 1, right hand side is for case 2. Next, we will consider finite duration sequences. First, consider a finite duration causal sequence. I have considered an arbitrary example of a finite duration causal sequence. This is the way that I have expressed the sequence 1, 2, 5, 7. These are the sample values. Just see that there is a vertical arrow below the number 1. According to this convention, wherever there is a vertical arrow, that sample corresponds to the sample value at n equal to 0. So this is the sample value at n equal to 0. 1 is the sample value of at n equal to 0. Therefore, 2 will be the sample value for n equal to 1. 5 will be the sample value for n equal to 2. And 7 will be the sample value for n equal to 3. 0, 1, 2, 3. And because the vertical arrow is here, it implies that all the sample values to the left of that instant are 0, and all the sample values to the right of that instant is 0. All those sample values will be 0. So this sequence extends from n equal to 0 to n equal to 3. What will be the nature of the Z transform of this sequence? Obviously, it will be, if you start from the basic expression, summation over n equal to 0 to infinity xn z to the power minus n. Then this is x0. Next term in the summation will be x1 z to the power minus 1. So 2 into z to the power minus 1. x2 into z to the power minus 2. That means 5 into z to the power minus 2. x3 z to the power minus 3. That means 7 into z to the power minus 3. So
Sir,
what
can
will
you
be
repeat this part?
This part? According to convention that I am following in such a representation of sequence, wherever there is a vertical arrow, that sample is the sample value x0. Therefore, the next sample is the sample value x1. Next one is the sample value x2. Next one is the sample value x3. And since no other sample values are given, it is implied that after x3, for x4, x5, x6, x7, etc., all those sample values are 0. Similarly, there are no sample values given prior to n equal to 0. X minus 1, x minus 2, x minus 3, those are not given here. So all those sample values are assumed to be 0. That is the convention that I follow. There are several conventions of representing sequences. So that is one. Therefore, if you consider the basic expression for Z transform, this was the expression. All right, this is the expression. Summation over n equal to 0 to infinity xn z to the power minus n. That means it will be x0 z to the power minus 1 plus x1 z to the power minus, it will be x0 z to the power minus 0 plus x1 z to the power minus 1 plus x2 z to the power minus 2 plus x3 z to the power minus 3 and so on. So x0 is 1, x1 is 2, x2 is 5, x3 is 7. So 1, 2, 3, 4 terms only. Because all other sample values are 0, therefore the terms involving those sample values will be absent, isn't it? So if you accept that this is the expression for the Z transform, then what is the ROC? Obviously, the ROC will be the entire Z plane with the exception of what? Z equal to 0, isn't it? Exception of Z equal to 0. Because this is 1, this term is 2 by Z, this term is 5 by Z square, this term is 7 by Z cube. So if you substitute Z equal to 0, all these terms, this one, and that one, they will become infinite. So magnitude of xz will be infinite for Z equal to 0. So region of convergence of xz will be the entire z plane except z equal to 0, because the magnitude of xz cannot be infinite in the ROC. So that point z equal to 0, the origin, it has to be excluded from the ROC. All right. Remember that there I considered the impulse sequence delta n. It has a z transform of 1 and the region of convergence is entire z plane. There the origin was not excluded, but here the origin will be excluded because the reasons that I have cited. So that is the case for a causal finite duration sequence. Next, have a look at a two-sided finite duration sequence consisting of finite duration causal component and finite duration anti-causal component. So this is the way in which this can be represented. The values, sample values have been arbitrarily chosen. So vertical arrow is here. So 8 is x0. The sample values to the right of this vertical arrow, they will be x1 and x2. Because there is no other term to the right of that, all those samples, x3, x4, x5, x6, all these samples will be 0. Similarly, this is the sample, 8 is the sample for n equal to 0. So that is x0. The samples to the left, 6 is x minus 1, 2 is x minus 2. Because there are no samples to the left of 2, all those samples values, x minus 3, x minus 4, x minus 5, all those sample values will be 0. So here we have a two-sided finite duration sequence. What will be the z transform? If you start from the basic expression, it will be 2z squared plus 6z plus 8 plus 5z squared plus 5z to the power minus 1 plus z to the power minus 2. In this case, the ROC will be the entire z plane with the exception of z equal to 0 and z equal to infinity. Because if you have z equal to 0, due to the presence of those terms, that one and this one, it is 5 by z, this is 1 by z square. So at z equal to 0, both these terms will become infinite. So magnitude of xz will be infinite. So z equal to 0 cannot be in the ROC. Similarly, if you consider those terms, this is 2z square, this is 6z. At z equal to infinity, both of those terms will become infinite. So magnitude of xz for z equal to infinity will become infinite. So z equal to infinity can also not be a part of the ROC. That's why I have written excluding z equal to 0 and z equal to infinity. All right. In the next example, you are having an anticausal finite duration sequence. Just see, this is x0. There is no sample value to the right. That means x1, x2, x3, x4, x5, x6, all these sample values are 0. There are only a finite number of sample values to the left. So x minus 1 is 2, x minus 2 is 3, x minus 3 is 5, x minus 4 is 9. All right. So what will be the expression for the z transform? This is the expression. So here the ROC is the entire z plane with the exception of z equal to infinity. Is that all right? Write down.
Sir, here R2 is equal to 0 means, please.
Because the general case is R greater than R2 less than R1, isn't it?
Yes.
So here that R2 value is 0 as a special case. You can have a mixed composition also. There may be a sequence that will have finite number of samples to the right of n equal to 0 and may have infinite duration to the left of n equal to 0. Or you can have a sequence that has an infinite duration to the right of n equal to 0, while on the negative side of n, it will have finite number of samples, non-zero samples. So you must be able to find out the ROC for such cases also. I have discussed about the infinite duration sequence, both one-sided and two-sided. I have discussed about the finite duration sequence, so you can just combine your observations. হয়েছে?
Yes.
So just note that a rational Z transform certain other properties of ROC. A rational Z transform always has, I have pointed out this point, this observation earlier. A rational Z transform always has at least one pole located on any boundary separating its region of convergence and divergence. Second observation is there is never a pole lying inside the region of convergence. And third one is ROC cannot consist of two or more disjointed regions. It must be a connected region, a continuous region. All right. So you may be asked to write down the properties of region of convergence. So you must just recall not only this thing, you must also write that magnitude of xz should be finite, etc., all these things.
স্যার
হ্যাঁ বলো।
স্যার ওই নোটের 1 নম্বর পয়েন্টটা একবার এক্সপ্লেন করবেন?
যতগুলো আমি এক্সাম্পল নিয়েছিলাম আগে, all the examples that I cited, there you have observed that wherever there is a boundary between the ROC and the region of divergence, a pole was lying there. Just see here. Where are the poles located? Here. এখানে z equal to b and z equal to a, isn't it?
Yes, sir.
So here this is a, this is b. So one pole is lying here, another pole is lying there. This is the one of the boundaries between the region of convergence and region of divergence. This is another boundary between the region of convergence and region of divergence. So there were two poles. So those two poles are lying on the boundaries. All right. If there were three poles, more than two poles, and two boundaries of ROC and ROD, then obviously the third pole would have lied in the ROD. But wherever there is a boundary, at least one pole must lie there. আমি যে আগের এক্সাম্পল নিয়েছিলাম, কোথায় দেখা যাক। এই এক্সাম্পল গুলো দেখলেই বুঝতে পারবে। তখন তো আমি মেনশন করেছিলাম। Just see here, this is a sinusoidal sequence. So what's the region of convergence? Magnitude of z greater than 1. All right. Where are the poles located? Here. One with argument magnitude of one with argument plus minus omega naught tau. So one is lying there, another is lying here. What is the region of divergence? The exterior of the unit circle. And what is the region of convergence is the exterior of the unit circle, and region of divergence is here, interior of the unit circle. There are two poles and they are lying on the boundary between the region of convergence and region of divergence. If you consider the earlier sequences, for the step sequence, what was observed? For the step sequence, this is the expression for the Z transform. Given magnitude of Z is greater than 1. So where is the pole located? Here, Z equal to 1. That is at the boundary. So this is lying at the boundary of the ROC because the region of convergence is the exterior of a circle centered at origin in the Z plane with unit radius. এই যদি একটা circle টানো, if you draw a circle, outside that circle is the ROC and inside that circle is the region of divergence. So here also, because there is a single pole and a single boundary between the ROC and ROD, it must lie on the boundary. So that is what is happening here. So as you move on to more and more expressions, more and more examples of Z transforms, you will find that if there are one or more boundaries of region of convergence, at those boundaries, at least one pole must lie. বুঝেছো? না বুঝলে বলো, একটু চিন্তা
হ্যাঁ
করো।
স্যার কিছুটা, আর একটু পড়লে, হ্যাঁ আর একটু পড়লে স্যার এটা ক্লিয়ার হবে ব্যাপারটা।
Now move on to inverse Z transform. If xz is the z transform of xn, then xn is the inverse z transform of xz. So there are several methods. I mean, quite a few methods for evaluation of the z transform, inverse z transform, sorry. I will consider two of the methods. Power series expansion is one, and partial fraction expansion is another. Partial fraction expansion is known to you, all right? So I will point out certain finer aspects of the power series partial fraction expansion that is solely valid for the z transforms of sequences, which was not there when you considered Laplace transforms. First one is power series expansion. You can easily understand what's the meaning. If the given function of z, xz, if you can express it into a power series, say x minus 3 z cube plus x minus 2 z square plus x minus 1 z plus x0 plus x1 z to the power minus 1 plus x2 z to the power minus 2, like that, a series. Then you can find out each of the samples. So you are intending to find out the sample values. There are two possibilities. One possibility is that you can obtain, as inverse z transform, you can obtain the values of xn for different values of n. That is one possibility. Alternatively, you can also find out in certain cases, in many cases rather, the expression for xn. All right, the closed form expression for xn. Say a to the power n un plus a to the power b to the power n u minus n minus 1. That is a expression for xn, isn't it? So both these possibilities are there. So in power series expansion, first write down this part, then I'll proceed. The easiest power series expansion method is that of long division. Long division is nothing. Don't get afraid by the name long, adjective long. It's simply straightforward division. Straightforward division. Let me cite an example. Say xz is z squared divided by z minus 1 into z minus 0.2. And the ROC has to be given, remember. Magnitude of z greater than 1. So, how will you find out? By long division method. What I mean here is that the rational function, you can express it as a ratio of polynomials in z to the power minus 1, and then it's better to first express it as a a ratio of polynomials in z to the power minus 1, and then carry out the division. Let me first point out. See, this is the expression that I have obtained. Now perform the division. Remember that magnitude of z is greater than 1. Therefore, the sequence whose z transform is given by xz, that sequence has to be causal. All right. Therefore, in power series expansion, we have to obtain a power series in terms of positive powers of z to the power minus 1. Or you may say negative powers of z, of the form x0 plus x1 z to the power minus 1 plus x2 z to the power minus 2 plus x3 z to the power minus 3. If you can express xz in this form, therefore from that power series expansion, you can pick up x0, you can pick up x1, you can pick up x2, you can pick up x3. So those are the values of xn that you desire. Just let me show how is it. Therefore, what I mean is that because it's causal, xz has to be expressed in this form. All right. Before the power series expansion, just I have applied the initial and final value theorems to find out the initial value x0, it is coming out as 1, and the final value is coming out as 1.25. I am illustrating the long division below. This is the expression. I have to divide 1 by the quantity 1, the value 1 has to be divided by 1 minus 1.2 z to the power minus 1 plus 0.2 z to the power minus 2. Just see here, I am dividing 1 by that expression. So first term is 1 on division. Because you are getting the first term as 1, what will be the term that you will get here? 1 into the whole thing. So you get here 1 minus 1.2 z to the power minus 1 plus 0.2 z to the power minus 2. If you subtract this term for 1, it is plain and simple division, the type of division that you learned at school level in your primary classes. If you subtract this one from 1, what do you get? 1 minus 1, that will vanish. Then it will have 1.2 z to the power minus 1 minus 0.2 z to the power minus 2. Now this 1.2 z to the power minus 1 minus 0.2 z to the power minus 2 has to be divided by that polynomial. So you must generate a term which is 1.2 z to the power minus 1. How will you do that? Because you have 1 here, 1.2 z to the power minus 1 here will result in 1.2 z to the power minus 1. If you put it here, you will get here 1.2 z to the power minus 1 times all these three terms. So 1.2 z to the power minus 1 into 1, that results in that term. 1.2 z to the power minus 1 into minus 1.2 z to the power minus 1, meaning minus 1.44 z to the power minus 2. Then 1.2 z to the power minus 1 times 0.2 z to the power minus 2. That means 0.24 z to the power minus 3. So you have got two terms, 1 plus 1.2 z to the power minus 1. Here, what will be the next step? You have to subtract that one from 1.2 z to the power minus 1 minus 0.2 z to the power minus 2. What will you have on subtraction? That term involving z to the power minus 1 will vanish. Minus 0.2 plus 1.44 z to the power minus 2. That is 1.24 z to the power minus 2. And here minus 0.24 z to the power minus 3. That comes in here. Next term will be 1.24 z to the power minus 2. And here you will have 1.24 z to the power minus 2 into 1. That means that term will be present. Next will be 1.24 z to the power minus 2 into minus 1.2 z to the power minus 1. So minus 1.488 z to the power minus 3. Next term will be 1.24 into 0.2 z to the power minus 2. That means 0.248 z to the power minus 4. So what will be the next term? Next term will be such that here if you subtract these two, what will you have? 1.248 z to the power minus 3 minus 0.248 z to the power minus 4. So next term should be 1.248 z to the power minus 3. All right. In this way, you can go on continuing the division. So what do you get? Xz, we know that Xz now comes out as 1 plus 1.2 z to the power minus 1 plus 1.24 z to the power minus 2 plus 1.248 z to the power minus 3, etc. So x0 is 1, x1 is 1.2, x2 is 1.24, x3 is 1.248 in this way. Now, according to your requirement, you can go on generating more and more terms. All right. What I would like to point out here is that just see x0 is coming out as 1, that is in conformity with what we have observed on applying the initial value theorem. X infinity, the final value is 1.25. Here just see, as you are proceeding with the division, ultimately xn is tending towards 1.25, isn't it? It's tending towards 1.25. So that is in conformity with what we have observed by applying the final value theorem. Now tell me whether this is clear or not. Simply primary level division. Write down. If you have any question, please ask. Problem with this method is that you don't get a closed form expression for xn. No expression for xn can be obtained by this method. Simply the value of xn for different values of n can be obtained.
Sir, how many times we have to find out the division will be go on and go on?
Yes, right. So how many terms you have to find out, that depends on your requirement. For here, you will find that after certain number of terms, it will become 1.25. In particular, in this example in particular. So then you may conclude that all other terms will be 1.25.
No.
Written it. Now I'm showing this long division. I don't think I'm not sure whether this is visible or not. Is it visible now? You can legible rather.
Yes.
After you have written it, I have one question to ask you. Done it?
Sir, I could not understand final value theorem. Please, sir, you explain it.
Final value theorem.
No, no, not that's calculation. Final value theorem calculations.
Is there any mistake here?
No, no, sir. Sir, here, how is the limit z tends to one term here in this case 0.2 z minus 2, but where is 1 minus 1.2 z in inverse?
Hmm?
So z minus
Oh,
1.
Z tending to 1. Yes. This was Z.
Okay.
All right. You have multiplied it with Z minus 1. So the Z minus 1 terms. Just see here that it's Z minus 1 by Z, meaning its limit Z tending to 1, Z minus 1. Because
Okay.
if you introduce this limit, Z will become 1. I pointed out. So xz has to be multiplied with Z minus 1. If you multiply xz with Z minus 1, that this term will get cancelled out.
Okay. Okay.
So Z square divided by Z minus 0.2, in that expression, you have to substitute Z equal to 1.
Okay, okay,
Right.
sir. Now I understand.
Hmm. You done it. If you have written it, then so this is XZ expanded into a power series. Therefore, you can just pick up these samples. X0 is 1, X1 is 1.2, X2 is 1.24, X3 is 1.248, etc. In the exam, of course, if you are asked to find out the inverse Z transform by long division, the number of terms will be mentioned explicitly. Division can be continued to generate as many terms as required. If you have written it, now just answer one of my questions. I hope you have written it. Say for this given XZ, I have considered the ROC as magnitude of Z greater than 1. Can you tell me what are the other possibilities? What other ROCs are possible for this XZ? Often we will be required to solve problems. So I could have given the problem in this manner also. Xz is equal to Z square divided by Z minus 1 into Z minus 0.2. And I could have just excluded this part. No ROC is mentioned. If that is the case, then this inverse Z transform has to be evaluated for all possible ROCs of XZ. Now tell me what are the different possibilities of ROC. For XZ, can you identify the ROCs? One is obviously magnitude of Z greater than 1. What are the other possibilities? For identification, you have to recall the you have to remember the properties of ROC. You have to understand the properties of ROC. No pole can lie in the ROC. And whenever there is a border between an ROC and a ROD, region of divergence, in that border at least one pole should lie. In this case, the ROC is magnitude of Z greater than 1. So what is the border of the ROC and the region of divergence? The circumference of the unit circle centered at origin in the Z plane. So obviously there this pole is lying, Z equal to 1.
Sir, sir, mod Z less than 0.2.
Right. This is another. Is there any other possibility?
Mod Z greater than
Mod
any
Z
other
in between 1 and 0.2.
Yes, right. So other ROCs will be magnitude of Z less than 0.2, and third one will be magnitude of Z greater than 0.2 less than 1. These are the three ROCs. All right. So what will happen for those cases? I have carried out the long division for magnitude of Z greater than 1. What will happen for those cases? Let's consider the case magnitude of z less than 0.2. That means in that case, the sequence that you want to obtain by inverse z transformation, that sequence has to be an anticausal sequence by virtue of the ROC being the interior of a circle centered at origin in the z plane. So how would you obtain? Same example. Xn is anticausal. So Xz will be of this form. It will be a series in positive powers of z. Series in positive powers of z. Just write down. How will you perform long division to generate a series in positive powers of z? I will end with this example. The division remains same. 1 is to be divided by 1 minus 1.2 z to the power minus 1 plus 0.2 z to the power minus 2. But now you have to get a power series of this form. Just see here. 1 is there. We are dividing 1. Just see in this expression, in the earlier case, we considered 1 minus 1.2 z to the power minus 1, then plus 0.2 z to the power minus 2. I have just interchanged the order, just reverse the order. 0.2 z to the power minus 2 minus 1.2 z to the power minus 1 plus 1. So what type of expression will it generate? To have 1, what should we multiply with 0.2 z to the power minus 2? 5 into z to the power minus 2. So if you have here 5 into z square, 5 into z square, that multiplied by 0.2 z to the power minus 2 will yield 1. So first term is 5z square. You have 1 here. So if you subtract, what will be the other terms? 5 into z square times minus 1.2 z to the power minus 1, that will yield minus 6z. 5 into z square plus into 1 will yield 5z square. So if you subtract it from 1, you will get 6z minus 5z square. So with what we should multiply 0.2 into z to the power minus 2 to get 6z? It will be 30z cube, isn't it? To yield 6z here. 6z minus 30z cube into 1.2 z to the power minus 1. That will yield minus 36z square. Then 30z cube into 1, 30z cube. You subtract, you get 31z square minus 30z cube. So in this way, you get more and more terms. All right. এটা হয়ে গেছে এই পার্টটা।
স্যার এখানে পয়েন্ট টু যেটা মাইনাস টু এর সঙ্গে ফাইভ জেড স্কোয়ার মাল্টিপ্লাই করে ওয়ান নিয়ে আসছি, তো স্যার আমরা যদি 1.2 জেড ইনভার্স তার সঙ্গে একটা কিছু মাল্টিপ্লাই করে ওয়ান নিয়ে আসা তো যায়।
হ্যাঁ, সেটা হলে কি হবে বলো?
তাহলে
তখন
এই
একটা পাওয়ার সিরিজ পাবে, ইউ উইল গেট a power series in both positive and negative powers of z to the power minus 1, or even say a power series in both positive and negative powers of z. That will be the case for the ROC magnitude of z greater than 0.2 less than 1,
রিং স্যার।
ring shaped. You're right, absolutely right.
ওকে।
হয়ে থাকলে বলো। হয়েছে?
Yes.
So this is the expression for xz. You can generate more terms. Therefore, x minus 1 is 0, x minus 2 is 5, x minus 3 is 30, x minus 4 is 155, etc. So that will be the nature of xn. On the left side, you can generate more and more terms. Okay, let me stop here. I will also consider what you have pointed out, the ROC magnitude of z greater than 0.2 less than 1. That, of course, you can do on your own anyway. So after completing that, I'll move on to the partial fraction expansion method. Not after that, we have other types of power series expansion where you have to use your knowledge about the infinite series expression for different types of functions of z, starting from exponential function to natural logarithm or log to the base 10, etc., etc. You have to recapitulate the infinite series expression for those type of function. Have you done it?
Yes.
Okay. So please inform me later when can we have the next class. Not tomorrow or day after. All right, after 3rd. একটু আমাকে শুনে বলো তো আমার কথাটা শুনতে পাচ্ছ কিনা, আমি জাস্ট এটাকে ব্লক করছি। শুনতে পাচ্ছ?
Yes, sir. Yes,
শুনতে
sir.
পাচ্ছ?
Yes, sir.
এটা কাজ করছে কিনা দেখার জন্য বলছি। শুনতে পাচ্ছ?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir.
ঠিক আছে।
Yes, sir.
ওকে, থ্যাংক ইউ ভেরি মাচ।
Thank you, sir.
Thank you, sir.
Sir.